Okay, welcome. It looks like it is 3:45, which is my time to begin, and your time to enjoy. So hopefully we'll both achieve our mutual objectives by the end of this presentation. My name is Rafał Lukawiecki, and I don't work for Microsoft. I have never worked for Microsoft, but I have worked with Microsoft for about 24 years now. In the last 7, almost 8 years of those 24 years, I have specialized in BI, analytics, and in particular in data mining. Data mining is the deepest area of my technical specialty. I do other types of BI too, but not as much. For example, yesterday I have run a full-day pre-conference seminar on Power BI. We talked about Power Query, Power View, all the other stuff, which I use and I know, but I don't use and I don't know as well as data mining. Data mining is really the thing I do, so you kind of came to the right session, I guess. One thing I want to point out is that until very recently, it was very difficult for me to explain what is my job. And especially when I said I do data mining, most people had no idea what is he talking about. But I'm very happy that as of about last year, I know what it is that I do at last. There is a name. I am called a data scientist now. So in case you've never seen one, hello, this is more or less what one is supposed to look like. Having said that, I'm not entirely sure this name will stay, because a data scientist, first of all, is not really a scientist. Okay, I am, but that doesn't matter. And also, it's a kind of a slightly hyped-up title for what basically is someone who does advanced analytics. And at the end of this session, if I am successful, almost all of you will be able to become data scientists if you want to put it on your name badge. All right. Couple of introductory things. If you want to stay with me, rafal@projectbotticelli.com at your disposal. Please consider following me on Twitter at rafal.net. I tweet pretty much only about business intelligence, or occasionally about photography, and I generally try to keep the number of tweets to the number of followers I have. So it's kind of within reason. So when I don't have enough followers, I stop tweeting for a while. Okay. This session is really about introducing data mining to you, demystifying it, and showing it in the way you can use it right now with just Excel and a little bit of SQL Server technology hidden behind the scenes. And in order to explain how both of those works, I hope not only I will give you a glimpse here during this session today, but I also hope that I will have a chance to invite you to visit our website at projectbotticelli.com, where amongst many other things, we have recorded full-length, I believe, the best on the planet, online video-based training, amongst other things, on data mining. Basically, we only do business intelligence. I do data mining. I also do big data. My colleagues, Alberto Ferrari and Marco Russo, who are the preeminent authorities on the data analysis expressions language, do DAX training. Chris Webb, who is the authority, interplanetary authority, in fact, on multidimensional expressions, is doing multidimensional expressions, and Carmel Gunn is doing Excel BI for corporations. And because anybody who comes to Las Vegas likes to get a deal, you know, when you come to Las Vegas, you get comps, right? You know what are comps? You know what are comps? If you don't know what are comps, that means you haven't lost enough yet. So good for you. Once you know what comps are, you should probably head back home. But in this case, I have a comp for you, and you don't need to even gamble for it. That comp is 1 month of free access to all of our training courses. Comp 1M 2014, Vegas is the code, but limited only to the first 250 people. And the last time I checked before the session, about 65 were already claimed. Why? Because I had a pre-conference yesterday, okay? So you kind of get second dibs on that. So make sure you claim it. There's about 600 of you in this room or more. So if everybody claims, you will run out. So I also have the consolation prizes, which are the other two. And the last one, 15% off, has no limit other than they all expire on March the 7th. I will show this slide once again at the end of the presentation in case you want to make a copy of those codes. What does data mining do? It does 3 things. First and foremost, it helps you explore your data in a different way to perhaps what you've been doing before. It finds patterns. Basically, it looks for correlations in your data. And optionally, although most people find that the most exciting part, I don't, but I understand that people like that, It helps you make predictions. In fact, most of data mining use does not require making predictions. You just use it to understand the patterns, what is happening in your data. And that's incredibly useful. But when you are getting started with it, it's nice to have a little bit of fun, and performing predictions is a fun thing to do. Just bear in mind, predictions don't mean predicting future always, although that's what most people think. You may want to predict the past. Why? To find out what really happened. And you may want to predict the present, which is actually the majority of predictions we do. What is happening right now? For example, a transaction is processed by your system. Now, is this transaction going to fail? Or is this transaction fraudulent? Or what can I recommend to this shopper? Those are examples of predictions that you can do for the present without worrying about the future. I like to stress it because predicting the past works well. Predicting the present works well. Predicting the future does not always work well. Why? Because you have to make a huge assumption that nothing else will change around you when you make the prediction into the future. And people who ask me to build forecasting systems for them have this idea that I can predict the next 2 years forward of their sales. Yes, I can, on the assumption that nothing else changes. And of course, everything else will change. So you can only predict into the future as much as you can assume the rest wouldn't change. Not a lot of time, not a lot, but it can be useful in some businesses. The most typical uses of predictive analytics start with understanding your customers a little bit better. And the first thing we want to understand about most of our customers is who are the profitable customers. Understanding why do they like something and they dislike something else. Predicting why or when will they say goodbye to you and move to your competitors. Predicting your levels of sales and inventory that you will require. Building better marketing campaign is actually one of the holy grails of data mining. The idea is that you can build such marketing campaign that only people who really want to hear from you will hear, and nobody else gets upset. This is very, very hard to do, and that is definitely one of the most challenging uses of this technology. Preventing and detecting fraud is a huge area of predictive analytics. Difficult to do, but when you can do it, it is incredibly valuable. Only recently, I have started working on a new project for a customer, a governmental customer in Europe, helping them spot social security fraud. It's quite extraordinary what you can do with very little work. With a fairly simple model that we've built, we were able to catch almost 80% of fraud by analyzing or sending investigators to only about 20% of potential caseload or potential candidates. It was quite a surprise to me how much you could do with so little. Very often because it's a low-hanging fruit. Very often because this technology, although it's not new, it's been around for more than 20 years. It's only coming to fore now, and it's a good year to be getting into it, which is why I'm happy that the room is pretty much full. Also, you could use this technology for a technical purpose to correct your data. For example, while you are importing data into your other systems, you may want to cleanse it by using data mining. I certainly see that technology being used quite extensively and successfully. Yes, I'm going to talk a lot about data mining, and I'm going to give you a lot of demos, but rather than just talk, how about I give you a quick first intro, just a glimpse of what it is about, literally a glimpse, no explanations other than what's necessary. Then I'll switch back to my slides, cover a little bit of the stuff you need to know, and then we'll go back to demos. And after we go back to demos, we'll stay in the demos until the end of the session. So let me switch over to my demo machine, and let me just give you a glimpse of very simple data mining that you can do in Excel. I'm opening here an Excel spreadsheet which contains information about my potential new customers. What you see over here are typical bits of demographic information that I have got for about 4,000 potential new customers. And what I want to find out as a data miner is what is unusual about this data set. I want to look for the outliers or the exceptions. And in order to do that, all I need to do is to install the free Microsoft data mining add-ins for Office. Once you have installed them, you will get this tab. This is the Analyze tab that has these lovely buttons over here, one of which we will press in a moment. And you also get this other, richer Data Mining tab, and we will press some of these buttons in the later demos in this session. And in case you are wondering, is it free? Does it mean it's pretty, like many free things? Well, no, it's actually pretty mature. Microsoft has produced this, hold on to your seats, already in 2005, available for Office 2005, 2007, 2010, and 2013. And you didn't know about it. So that's a good thing. That's actually an excellent thing for my company, because I've built my business on the fact that it's there. And most of my customers don't have to pay for this technology because they already have it. It's like, we already have it. Yes, you already have it. You know, this is pretty cool stuff. Now I'm sharing the secret with you. Okay, there is another part of technology you absolutely have to have. Somewhere out there, you have to have a SQL Server Analysis Services, which is basically SQL Server from Microsoft, starting, realistically speaking, with version 2008 onwards. 2008, 2008 R2, 2012, 2012 Service Pack 1, they are all fine, and so is 2014. If you really, really wanted to use historical technology, you could even make some of it work with SQL 2005, but I don't recommend, because it was a little bit buggy at that time. So pretty mature, pretty much proved by now. Let's see how it works. I've selected my data over here. Let me just select the table. I go to the Analyze tab, and this is the button I want to press. Highlight exceptions. And when I press this button, and I press the Run button, the data is sent to SQL Server, which is looking for patterns at the moment. Now it found the patterns. It's checking whether every row of data is or isn't potentially an exception. And it told me that it found 155 exceptions, in particular with regards to the birth dates, the total children attributes, and so on. But there are no exceptions with regards to gender or marital status. It thinks that everything is absolutely fine with the data regarding that. So let me show you some of those exceptions. Those exceptions have been highlighted in yellow. And I want to discuss 2 or maybe 3 of those exceptions that I'm quite familiar with, because I've been showing for a long time now. Here is a lovely lady. Her name is Jacqueline Murphy. And look, she is an exception. Can you see the brighter yellow column highlighted? Because she was born in 1901. Now, perhaps she was born in 1901, and perhaps this data set is simply not representative of the fact that I don't have many people who were born in 1901, but it is an exception. Having said that, most of you realize that you don't need any kind of SQL Server, this and that, to simply say that people who were born a long time ago in a data set that has mostly people born recently makes an exception. So you're probably now questioning, why do I even need data mining to learn that? Well, you don't. But I wanted to show you an easy exception to understand before I show you more complex ones, okay? So just to do that, you don't need data mining. Calculator would be enough. However, look at this exception. Bailey Hall is an exception because she has 4 children at home. Can anybody see what is strange about this row of data? She has no children, exactly. Now, maybe she runs a creche, and maybe those children happen to be children from her family. There may be other reasons, but SQL Server doesn't know that. All that SQL Server could figure out is that it's an unusual combination of parameters. No, I did not tell it anything about this data set. I started just with the data and just that button. And all of you who would do that, just press that button, would get the same result, because this combination is not typical. Okay, but it kind of made sense. This is probably an error, maybe data entry error. Let me show you yet another exception. Let me find my good friend, Gerald Malhotra. I like talking about Gerald Malhotra. I've been talking about him for many, many years that I've been teaching and practicing data mining. And the story of Gerald is easier to explain in Europe than in the United States. So I fully expect that you might not connect with why it is funny. And Europeans in the audience, you will find it funny, but the Americans, you might not get the joke. So never mind, the explanation will work even if you don't find it funny, okay? Why is Gerald an exception? Well, let's look for the bright yellow thing. No bright yellow thing yet here. So let's scroll to the end. Gerald is an exception because he has only one car. But you can see that there are other people who have only one car, and they are not exceptions. So why is Gerald an exception with one car, whilst the rest is not? The reason for that comes from understanding the values of all of the other columns, all of the other attributes. You see, Gerald has quite far to travel, and he is a male, and he has respectable income, and he is single, and he is in a prime of his life. And because this data comes from the United States, a typical gentleman with these parameters should already have 2 cars. Okay? You are a great audience. Thank you very much for that. I appreciate that. Even the laughing Americans, I appreciate that too. You see, in Europe, this doesn't work because in Europe, having 1 car is kind of normally good enough for most people. However, if you want to do this, if you travel and you want to do this, for example, in Netherlands, switch the name of the column from car ownership to bicycle ownership, and they will completely get it. Okay, what you have just seen is data mining. But you don't even need to know it was data mining. All we've done is we've clicked this one easy-to-use highlight exceptions button. And that's my point. Excel makes data mining so easy, sometimes too easy, that you don't need to even know about it to use it. Of course, if you know something about it, you will benefit from it even more. And that's what I would like to do now. So I'm going to close this particular data set, and I'll switch back to my slides to explain a little bit more about data mining. I'll try to go through the slides as quickly as I can so I can go back to my demos, because I would like to show you 4 or even, maybe if I manage, even 5 demos of other examples of how you can use data mining in Excel, just to tantalize you with the potential, with the possibilities. And the first thing we need to get over is that when you are data mining, your data has to be structured in a particular way, which some people find unusual, other people find it very normal. Let's talk about inputs, and let's talk about outputs. The inputs to data mining are columns. Columns which represent things you want to analyze. For example, age, gender of a person. Those are often referred to as attributes. But also, you very often want to have flags. This person purchased a home. This person purchased a purple product that you sell. Often, these columns will be aggregates. The total spend of this person, the number of complaints they have made, or phone calls. And sometimes, this column will contain relationship-related data. In other words, what was the spend of the partner of this person that is related to this person according to your system? Now, I presume some of you in this room are familiar with databases, like most of you, right? Even if you use SharePoint lists, which are not really databases, but that's okay. Sorry, no offense. Don't get upset. What do database people like to do? Begins with N. N. Normalize. Very good. Normalize means that whenever they see a lot of flat data, they say, now, we're going to put it in multiple tables, and we kind of connect them with relationships. And you can spot a good database person when you visit their home, because you can see that even on the table, everything is kind of normalized in a way. And, you know, they start to be obsessive about it. When they kind of go and look at data and it's not normalized, they are twitching to add that table in a relationship. Well, when you are data mining, and you have one of those traits of your character, you will find it very difficult because you have to undo everything you know about normalization, because you have to flatten the data to the ultimate possible level. Basically, it's supposed to look like a SharePoint list. We want it flat. How flat? So flat that there will be duplication. For example, if I want to find out about the sales of a product to a person, and this person bought 5 products, and this person lives in Kansas and is female, born on this year, then I want to have 4 rows saying Kansas, female, this year, product 1. Kansas, female, product 2. You get the idea? So you end up having enormous amounts of data. It's actually big data, but we don't call it big data because we were able to cope with it, like, for 20 years, so it's just another, new term. However, what's very important too is that it's not just a lot of data that you suddenly see as rows, you will also have a lot of columns. How many columns? 8,000, 10,000 is quite typical for large projects. And if you think this is very complex, trust me, SQL Server and Excel will cope with it very well indeed. In some cases, you might need to use a little bit more SQL and a little bit less of Excel, simply because of the way you work. But both of those tools will work fine. So those are the inputs. Now, the output is what you want to study. Output could be risk of fraud, ability to purchase your newest widget, happiness level, how many cars will this person buy from me, probability this transaction is fraudulent, or that it will simply fail. Indeed, you could be predicting not one column, but even a set of values in one column. For example, products to recommend to the person who is currently looking at this product, which is rarer. However, it's also possible to have no output whatsoever. Sometimes you want to data mine just to find the structure. For example, when you do clustering. When you are doing clustering, you are finding categories, how things are different from each other, and you don't care about any outcome. Incidentally, that's what is known as the difference between supervised and unsupervised learning in the machine learning or data science lingo. So how do you data mine? 3 steps. Define the model, train the model, validate the results. Define the model means decide what are the inputs and the outputs. Train the model is also called processing cases because in data mining lingo, each of those rows of data is called a case. That's just another name for it. And this is what is done by SQL Server under the command of Excel. And then, before you dive into the results, you should validate them. I will show you a little bit of validation in this session, but I have to make it clear to you that validation is far more important and difficult than what I will show you in this session. And I have a whole 2-hour presentation with a video on our website which explains validation. It's called Mining Model Testing. And if you don't watch that and you watch the rest, well, then you are not going to be very happy with your results, because it's very easy to get results, but it's very easy to get results which are meaningless. Validating the model is extraordinarily important. So in terms of what is happening, you start with a defined but empty mining model. Then, because you train that model with your input cases, your data mining engine fills the model with a pattern. And you could stop now. You could just look at the pattern and you know something that you didn't know before. Like, for example, people who buy that are more likely to buy this. But you can go that one step further, and you can supply the mining model with new data on which you wish to perform predictions. For example, you built a model of customer profitability, and now you have new customers who are not yet your customers, and you apply this model of profitability to the new customers to generate their profit potential. As a result, you can decide which of those customers you are likely to send a bottle of an expensive Pinot Noir, because you might not have enough money to send it to everybody. Of course, you should send it to everybody, right? Let's talk about tools. On the back end, it's SQL Server. And as you already know, it's that component of SQL Server which is called SQL Server Analysis Services. No, you don't buy it separately. It comes with SQL Server. It comes in the Standard Edition, in the BI Edition, in the Enterprise Edition, and many of you will be surprised and many Microsoft people will be disappointed that I say that, but even the Standard Edition has data mining technology in it. However, most of the data mining technology customization and fine-tuning is only possible with the Enterprise Edition. Having said that, the Standard Edition is perfectly usable, not just whilst learning, but even whilst doing it for a customer. So don't wait for something you may not necessarily have. Try with the Standard Edition. It will work. And now comes something really confusing. It's very, very confusing. It's the packaging of technology. In order to install SQL Server Analysis Services, starting with version 2012 of this product, you get a choice of 2 types of SQL Server Analysis Services. One is called multidimensional and is famous for running cubes. And the other one is called tabular. You have to install the one which is called multidimensional. At this point, people think, that means I'm going to be mining cubes. That means I have to build cubes. No and no. This is just very strange packaging. You install the multi-dimensional version, but you never, ever have to even know what is a cube. Because the data mining technology is a little brother of the bigger technology, which most people know as the OLAP technology. So you install it, but you don't use it. Incidentally, could I mine cubes? Yes, you can. It's very unusual. I can think of only no more than 4 or 5 times in my life that I have done it professionally. Almost all of the other mining is on this flat data. No cubes will be harmed in the process. In terms of the front end, of course, this is why you came to this session. This is where Excel comes in play. This is where Microsoft Office Visio can also be used. And whilst at it, let me point out that I am very pleased that Microsoft launched Power Query recently, because that was a very big and missing component in data preparation terms. Before I mine the data, I like using Power Query, if I am using especially Excel, to do a little bit of cleansing, to import it, to mash it up, and so on. So use Power Query to import. You don't have to, but that's definitely a great tool for the purpose, and Excel as the front end with those free data mining add-ins. You could also use Power Pivot to derive missing data, but if you do that, it's not very convenient, actually, because unfortunately, the data mining add-ins don't work. They cannot access the underlying data model. The data for data mining add-ins has to be in the Excel sheet. I hope Microsoft change it in one of the next releases. I know that the manager, that the guy in charge of development of that is in the room. Is he? Could you raise your hand? Is Yigal in the room? Okay, he's hiding or he didn't come to my session. Okay, that's a problem. I thought I was going to, I'm meeting him later anyway, so I'll tell him that I told you. So how do you solve this problem? The way to solve this problem is you create a flattened pivot table. If you do decide to use Power Pivot and you do some data derivation, then you simply create a flattened pivot table which sucks out that data from the model and displays it in front of the user. And of course, you could also toy with using Power Query in the opposite way if you wanted to. I haven't tried that yet. The other tool that you may want to use is SQL Server Data Tools, which comes with SQL Server. And I'm not going to hide from you, this is the tool I use most of the time. Why? Because Excel is great for quick data mining, for easy data mining, and that's the title of the session, easy data mining. But if you are going to be doing it over and over and over again, it's nice to have a concept of a project where you don't have to start in the wizard at step 1 every time, but you can start wherever you left off. And that, unfortunately, is not available in the Excel interface. However, it is in SQL Server Data Tools. And finally, you could use SQL Server Management Studio and write queries. You could write those invocations to the data mining engine in a language called DMX, which looks very much like the SQL language. DMX stands for Data Mining Extensions. And if you are a scripting kind of a person, this is definitely a good choice for you. Okay, I also use one other tool that has nothing to do with Microsoft that I wanted to mention to you because it is phenomenally useful if you are going to become a data scientist, whatever that means. I use R. That's what it's called. It's called R. And if you don't know what's R, visit that URL of those, simply search for R statistics and or send me an email. R is an open source, free, and today, the leading statistical calculations package on the planet. It has now outshone everything else, including the industry leaders from the past. It's used by pretty much every large pharmaceutical company running double-blind, placebo-controlled studies and so on. It's used by anyone who is anyone in the world of data science if they are currently learning it in the university and will be leaving university, they will know R. And R is not the easiest, but not the most complex, but it's great and easy to start quick. Why do I use it in conjunction with SQL Server and Excel? Because it gives me a few additional statistical tools which are great for model validation that I don't get in SQL, but also it has a few other cool things for descriptive analytics For example, for finding out, is this data dirty without having to analyze it in depth? And there will be videos on our website on those uses of R2. So let me put together all of those components so you understand what happens in the demos. You start with a SQL Server Analysis Services server that has data mining algorithms provided by Microsoft. Now you use Excel or any of the other tools to deploy what? An empty mining model. This mining model has been defined by you, but it's empty. So what do? You train it with your data that comes from Excel, from a Power Query, that comes from SQL Server, from wherever you want. And as a result, we have patterns. And you can see those patterns in Excel, in Visio. You can visualize them in reporting tools, even in your own applications, because you can speak to the mining model using those well-known and well-mature protocols. And optionally, if you want to, your application can also ask questions to the model. Questions like, hello, model, will this transaction fail? Is this shipping address correct? What are the preferences of this customer and what should I recommend to them? There you go. That's the whole process. That's all the components together. And the only thing that prevents me from actually diving in and showing you all of that stuff is that I actually have to tell you very briefly what are those algorithms. No, I'm not going to explain all of them because you'd fall asleep and never leave the room. But I'm just going to give you a hint that I listed them on this slide in the order of their frequent use based on what my customers do. Without a moment of doubt, decision trees are the most fabulous data mining technology out there, not necessarily because they are the most accurate, but because they are the easiest to understand, to use, and to interpret. They tell you so much about things that are hiding in your data. I will show them to you in my demo. Association rules are primarily used for predicting recommendations. And that's one of the things almost everybody wants to do nowadays, so it is obviously very popular, and I listed it high up on the list. Clustering is a little bit more boring, but very useful. It helps you understand how things group. In other words, what are the natural differences, for example, between your products, employees, or customers? Naive Bayesian classifier is one of the oldest data mining techniques on the planet, invented over 200 years ago by Reverend Bayes. And that was created for early analysis of what constitutes patterns, and it's typically used today to figure out which columns, which attributes are important. In other words, it looks for certain simple but for interesting correlations between inputs. Sequence clustering, rarely used but very interesting combination of clustering with Markov chain analysis. That's a nice sound bite, you can repeat if you want. Sequence clustering predicts what will happen next. It allows you, for example, to predict the next click that the person will make on the website, or to predict the next transaction this customer is likely to perform. Time series is used for forecasting, especially for predicting numerical future. It combines autoregressive integrated moving averages with a Microsoft technique known as autoregressive trees with cross prediction. Both of those available actually since 2008 are true in all versions of SQL Server. Neural networks, name sounds good. They are very useful. Sometimes they can be the most accurate technique for finding complex patterns. Yes, they are used quite a lot in fraud predictions. They are used also in credit scoring, but I have a problem with them. They can be the best algorithm in terms of accuracy, the one that you check over and over and over, and it gives you the most accurate prediction. But there is one huge, huge problem with them. It's almost never possible to understand why they gave you the answer they gave you. So what you get is a black box. And I have a problem with black box solutions. Like if I build a fraud detection system which uses decision trees, I can explain why we think this customer is likely to commit fraud, because I can find in this huge tree where the system is classifying the customer. When it's a neural network, the customer calls the bank and says, can I have a loan? And the bank says, no, you can't. And the customer says, why not? And the bank says, computer said no. That doesn't make customers very happy nowadays. And finally, linear regression and logistic regression are simplified versions of a regressive decision tree and of a neural network algorithms, and they are useful, but I'm not going to talk about them now. Rather than that, I wish to congratulate you for having survived the slide portion of the PowerPoint presentation, because the only thing that is after the demo slide is the summary slide. So basically, this is my chance to show you pretty much all of that, well, maybe not all, but almost all of that, in the next series of demos. All right, so let me switch over to my demo machine. And, oh, I just got logged out. Sorry about that. There we go. All righty, where do we start? How about we'll do a little bit of forecasting? A little bit of forecasting, numerical future forecasting. So basically, the algorithm here will be time series, but we don't need to even know about it. What you need is data that looks like this. Basically, you have some kind of a timestamp, which should be regular with no missing gaps if possible. And then you have some numerical data that shows, for example, in this case, 3 series. Sales in Europe, sales in North America, and sales in the Pacific region. And by the way, as much as possible, I am using sample data that you can download. With the exception of one data set, which you can download from our website, all of the other data sets are Microsoft's. And when you install the free data mining add-ins for Excel, you get that data set with it. So you can replicate all of the steps of my demo if you wanted to. So what you will do is you will select the table, you will go to the Analyze tab, and you will hit this button, the Forecast button. And it asks you, how much future should I predict? Well, 5 is typically as much as you can whilst it still works. Beyond that, be careful. Make sure you predict the variance in case it becomes out of whack. And when I hit Run, it finds if there is a pattern, and it shows me what will happen later. And there you go. The broken line is the prediction. The continuous line is the known past. And look, it even predicted seasonality. Can you see those patterns repeating over here? How does it do it? The algorithm actually listens to the music in your data. It's a nice way to put it. Basically, what it's doing is a fast Fourier transform detection of harmonics. That's exactly what you do when you are encoding music into an MP3. Fast Fourier is the underlying algorithm that creates MP3. So that's what it does. It listens to the frequencies, and it found the frequency. Sometimes it will not find the right frequency, and then it's good to parameterize it by telling it that your data has a monthly, quarterly, etc. frequency. But once it knows what that frequency is, it overlays the prediction by blending together autoregressive trees of those 2 types. And there you go. You get the results nicely as a graph, but you also get the results now added over here at the bottom of the table. Okay, time series explained, done, check, move to the next one. I told you it's easy. It's like, you now think, why did I even come to this session, right? It's just press those buttons. I know, it's easy stuff. All right, let's do some clustering. Let's do some clustering, but this time, I'm going to use actually Power Query to get the data from a SQL server. Not because I have to, but I just want to show you how easy it is. In case you haven't seen Power Query, oh my, it's going to really, really make your lives easier when it comes to getting data. And if you think, oh, yet another of those things that we don't know whether it's going to, no, it will work out. Microsoft will be big with Power Query. It's one of those things that we'll succeed with. There you go. There's Power Query over here. And using the Power Query tab, I am going to get data from SQL Server. But I know it's not a Power Query session, but I just want to quickly show you the wealth of things you could get the data from without knowing nothing about those data sources. Or over here, look at that. Woo! You can get data from SharePoint lists. It's at the top. I didn't move it, you know? Obviously, Microsoft heard you. You can get data from places I would even never think of getting data from, like from the Active Directory or Microsoft Exchange or Facebook. Who uses that? All right. In my case, I'm going to go to SQL Server, of course. I have a SQL Server running locally on this machine. Let me just type in the name of my server. And yes, shows my age. Happy days. No, it's happy cars. So there you go. That's my server. To those of you at the back, you now can see what the others were laughing. And OK, and it will show me all of the tables which are available in my Happy Cars database. And one cool feature, when you have the mouse pointer, look, it shows you on this flyout a preview of what's in the data. This is really neat. And yes, customers is actually the table I want. So when I just double-click on that, the Power Query window opens, and it allows me to do a little bit of data cleansing. For example, if I didn't want some of this data, if I didn't find it interesting, I could just select the column, and I could remove the column by clicking the Remove Columns button, and there you go, middle name is gone. And if I decided that, for example, I had a problem in this column because my female and male was coded unusually, you'll be surprised. In some older systems, for example, you will see that there are males and W and women, and that might require changing. You don't need to ask any database person to help you anymore. All you need to do is hit this button, Replace Values, and I'll just do it for the fun of it. Oh, I will not, because my other data set uses the same. Okay, you'll have to trust me on that. Value to find, replace with, click OK, and it changes everything. And I know it's not a session about Power Query, but I'm so excited about it. Everything you do is a step, and all of those steps are actually a scripted language called M. New language from Microsoft called M. That's it, okay? You should have come to my pre-conference yesterday, all right? So next year, spend that extra $400. I've got the data. I'm simply going to close the Power Query window. I click Keep, and it pumps the data into the Excel spreadsheet from the database. That's how easy it is, and the query remains here. Incidentally, if I was working on a project, I could share this query with others, but I'm not going to need to do that. What I'm interested in doing, as my first thing for you, is to do a little bit of clustering. So I could select all of the data, but it kind of gets a little bit boring having to select it. So instead, I'll click on a different button when I get to the right step on the Analyze tab. And on the Analyze tab, what I really want to do is hit the Detect Categories button this time. So let me click this, and it already knows that I probably don't want to be looking for patterns in names. It did a little bit of quick look at the data and decided that that wouldn't be very helpful. And the number of categories that it will detect will be auto-detected. Well, I don't want it to auto-detect. I actually want to force it to create only 4 categories. Why? Because I want to explain those categories to you. And if I don't do this, it will detect about 10 categories, and I will not have enough time in this session to explain them. So just to shorten the demo, I'm forcing it to have only 4 categories, even if it is probably not as accurate as having a few more categories. All righty, so let's hit the Run button. The data is being sent to SQL, which is now detecting the patterns. And once it found the patterns, it shows me that it detected these 4 categories, and the count of rows in them is such that the first one is biggest, the second is about half, and the remaining ones are slightly less than the previous. But, well, it doesn't tell you what these categories are. And that's exactly what clustering does. It finds the clusters, but it's up to you to understand what they mean. And you may find that when you've got a lot of clusters, understanding what makes a cluster is in itself a project that can take days. But if you do it well, and if it's valuable to your company, you will give them a way to understand customers and sales, which is so much better than anything they've done before. How do people look at sales? Sales in the south, sales in the north, sales in the east, sales in the west. But that hides the truth. How about if you actually have a pattern that sales to wealthy, rich families are very different than singles who are just starting up? How do you find out that that's meaningful? Well, that's what clustering could do for you. So let's have a look at our 4 categories over here. This is half of the explanation, and the other half is over here. For example, I can see that category 1, with regards to, let me just choose a different column than the date of birth. Let me choose, for example, the yearly income column. So I'm selecting yearly income from the normal, oopsie daisy, let me just do it once again, yearly column from the filter box. Oh, sorry, I just didn't do that. That I should. I selected in the wrong place. Once again, let me select the yearly income. Hello, scroll bar over here. And that's what I want to see. People who are blue have incomes greater than 100,000. Yellow are pretty good. Gray are in the middle. Red and light blue are the lower incomes. So basically, you can straight away see that category 4 will be the richer. This one will be relatively well-to-do, but these 2 first categories are lower income people. So you can already see that income is important. But really, if you want to understand what these categories are, you have to read this stuff. You have to actually read that. Category 1 has people who have, let me just make it a little bit more readable for you. This bar displays so-called relative importance. The longer it is, the more important that particular value is to this cluster membership. So in category 1, we have people with a lot of children, with good jobs, professionals, very high incomes, generally people who have lived on this planet for, a while. Let me call category 1 the big, rich families. Let's have a look at category 2. Clicking over here, I simply look at category 2 now, and I can see that category 2, well, they have lesser incomes, and they most certainly are in partial college, partial high school. They have some children. Well, you know what? Let's call them maybe could do better. Having looked now at category 3, we can see that these people have absolutely no children. They were born rather recently, and maybe they are still working their way. So we are going to call these just starting. And finally, we have category 4, and in category 4, we have people who have no children, very important, very big incomes, kind of good degrees, good jobs, but they are generally single. So they've got the job, they've got the money, but they haven't got the life yet. Wealthy singles. Okay, what I've done for you in a few minutes is what you would normally take a few days to do. There are additional visualizations which I am not going to show you right now, but you can see in my video on clustering, 1.5 hours, that show, amongst others, the tornado chart, which is particularly useful when you're looking for discrimination between different clusters, as you are fine-tuning the understanding of those clusters. But look what Excel has done. When I click back on my sheet over here, look, it appended at the end of every person which category they belong to. In other words, not only I have categorized everybody, but I can now sort them. For example, actually, let's not sort it, just focus on big, rich families. I can click, oopsie daisy again, I can click OK, and I know exactly who I want to be marketing my, overpriced Pampers or whatever is the right product. I'm probably not supposed to mention any trade names on this. Sorry, that was just illustrative. It wasn't any statement about the quality or the price of this very good, well-engineered product. Okay, so you've just seen clustering, and clustering already told us so much about your customers, but could we dig deeper? Could we find out something more specific about what makes them want to buy from me a lot of cars? Because my fictitious company called Happy Cars happens to be a car dealership. So to do that, I want to show you decision trees now. And in order to show you decision trees, I'm going no longer to use the Analyze tab. I could use it using the first button, this one, Analyze Key Influencers, but I'm actually going to use the slightly more grown-up Data Mining tab. And why will I do that? I will explain in a moment. But first of all, let's build the model. So I could select the data again, but it's not necessary to do that. You can just stay on the page where you are with this table, and you go this time to the button called Classify. Incidentally, there are buttons that help you explore, clean, and sample your data, most of which functions are now easier to do with Power Query. Then there are buttons for modeling, then for accuracy validation, and then very important buttons that help you use the models, as well as manage them and change the connection to a different SQL server and trace what's going on in case things are going wrong. So that's your pretty much full toolkit. In my case, I'm going to use the Classify button. The wizard is asking me to, it's actually telling me that I cannot continue because I have a filter applied. It's unfortunately a silly limitation of the tool that if you have a filter applied, it won't let you go further, which means that if you want to do data mining in Excel on filtered data, use Power Query. In the past, you couldn't. You actually had to copy the data to another sheet. It was like, laborious. Now it's so much easier. Anyways, back to building that decision tree. The Classify button hopefully will not complain now about anything. Yes, my data is in this table, and now it's telling me what is it that you wish to analyze. When you build a decision tree, you have to have an output. And the output, in my case, is the number of purchases that the customer is likely to make from my company. I basically want to find people who are likely to buy 4 or 5 cars from my dealership. As inputs go, please do not look at the first names and the last names, and please do not look at that category that we have just generated in the previous step, because that would heavily skew the model. However, this is a very good technique to know about, because that allows you to build something that's known as ensemble models. If you want to know what are those models, it's basically a model built from a model built from a model. Basically, one model creates an output that you treat as an input to another model. And whoa, can you imagine what you can do with those? Just be careful that every model is valid. Because if you don't check for validity, the error will start compounding so much that eventually you'll get a model that tells you what you want it to tell you, which is kind of what some of my customers unfortunately have been doing. By the way, there's another button you should know about, parameters button. Every mining technique comes with ability to be parameterized, and I explain every single of those parameters in my in-depth videos. It's in the boring part at the end of every video. However, I should have said also that when you view our videos, there are chapter links, and we are pretty proud, because when you click on a chapter link, provided you are in a relatively well-connected part of the world and your internet is not failing today, when you click on a chapter link, it seeks in the video in under a second to the right destination, even if the video is about an hour or 2 hours long. Make use of that feature if you visit that, our website. Anyways, in my case, I don't need to add parameters. I just want to go further, and I want to quickly point out something. Percentage of data for testing, 30. This is something that I'm not going to explain to you now. I will show you the chart, but this is known as hold-out testing, where you reserve some of the data on the side, in this case 30%, and it's used to validate that the model is accurate. This is known as holdout testing and is fundamental to drawing a chart known as a lift chart, which is one of your first tools to see whether a model is or is not working. In my case, I'm going to show you that chart and a little bit more about it, but not right now. So let me just give this structure a good name. I'm going to call it, what are we doing? We are looking for number of purchases. So number of purchases is what I'm going to call my mining structure. I'm going to call my model exactly the same name, and I'm going to hit finish, and the data is now going to SQL Server. SQL Server is training the model from the data which is over here, and as soon as it found the model, it displays the results. So let's have some fun, and let's see what's going on over there. And by the way, this is so fast nowadays. You know, when this technology was built, and that's, you know, almost 10 years old for Microsoft, almost 20 years old in general, to do what I have just done would have taken minutes. And now it's like lightning fast. And it's pretty amazing how big the data can be before it starts slowing down. I mean, if you throw millions of rows of data at it, which to most of us is big data, even a relatively small SQL server will cope with it. And is that big data? It is, but without any of the complexity of big data in this case. All righty, what are you looking at? Maybe to some of you, this is the first decision tree, in which case, welcome. If you have seen it before, then enjoy my explanation. I want to explain it well, because it's easy to understand if someone explains it. Otherwise, it is a little bit strange the first time you see it. The color bars that you see represent either, choose whichever term you prefer, the number of people who did that thing that I am analyzing, or the probability of doing that thing. And what's that thing? That thing is buying a certain number of cars. How many cars? The legend tells you. So, the reddish people bought 1 car, bluish 2 cars, greenish 3 cars, purple 4, yellow 5. And only 19 people bought 6 cars from me, only 1 person bought 7, so you can't even see the color bar for them because they are so few in this data set. So you can already see with that histogram, if you kind of twist your head, okay? Can you see what I'm saying? If you do that and you look at the slide, it's actually a histogram. Can you see? You can already see that most of my customers buy 2 cars. But today, my boss wants to send that expensive Pinot Noir to 4-car buyers, so I need to look for purple people. How do I find more purple people? Well, this is what the decision tree will tell me. The decision tree already shows you that if you want more purple people, you want people who have incomes greater than 100,000. Make sense? And that's what the decision tree told us. But you know what? My boss is not very generous, and he doesn't want to give me enough money to bring this expensive gift to everybody with a big income. He wants me to be more selective. So I need to choose further within those who have big incomes, those who are really much more likely than the rest to be buying 4 cars from me. How can I know that? Well, that's exactly what will be revealed to you when I press the plus button, because on the next level of the decision tree, you will see what is the important attribute number 2. I'm sure you want to see it, but you have to wait, because I'll show you something else in the meantime. I want to show you the dependency network. The dependency network is another visualization that shows you the relative importance of all attributes. In this case, to number of purchases. If I had more outputs, you would see more blobs over here. And as you see, the most important attribute is yearly income, followed by total number of children, level of education the customer has, occupation, birthday, basically age, commute distance, and the number of children at home they've got. And this slider is a percentage-based slider. So about in the middle is a 50-50 chance of being important. So you already know that income is important because that appeared at the top level of the tree. But the question is, which of those remaining attributes will appear at the next level? And you may think that it will be total children because it's the second most important attribute. But that would be looking at all of the data in a flat way. But we are not looking at it in a flat way. We have a tree. We are no longer looking at everybody. We are looking at a segment of people with very high income. So within that group of people, any of those attributes could be important. And that's why it's a tree, because at every level in a tree, a different attribute can play different level of importance. So, you've paid the price of waiting. Let's see which one did it. Dun, dun, dun. How interesting. The level of education. What I want is people who have a lot of money, but not too much education. I should point out that this data set, which you can download from our website, is not a Microsoft data set, and it does not represent reality. We cooked it a little bit. Why did we cook it? Because we wanted, to make data mining learning a little bit less, more entertaining. So what you are seeing is not real stuff. It's just made up, okay? But that's the only thing we have messed up in the data set. All the rest is real. So this is the only exception to reality. Alrighty, so I know that I am choosing these guys today, but tomorrow my boss says your job is different. Now we are going to be focusing on people with very low incomes. And when you focus on people with very low incomes, indeed, education also seemed to matter. But for people with medium level of income, what mattered more is how many children they had. And for people with kind of mid to high incomes, and very much higher incomes, you see different attributes appear at different levels of the tree. Let's drill for a moment this group, people with incomes of 25,000 to 50,000. What could matter to them if, for example, they happen to have 2 children? Well, on the next level of a tree, you realize that their age matters, and then what matters is again the level of education. Whilst for people with higher levels of income, who have 4 children, what matters is also education. But if they happen to have 2 children, also education. Oh, I thought I had a different one. I must have cooked this set too much. Let me just find another one. Where's the one I wanted to see? I may have removed it. Okay, that's the one I want to see. All right. And for people with lower level of incomes who do not have partial high school education, what matters the most next is how far they've got to travel to work. So effectively what you are seeing is that at every level of a tree, a different combination of attributes and their values determines the relative likelihood of belonging to a certain class of interest. It sounds complex, but it looks simple. And every time you run a decision tree, if you forget how does it work, remember the magic word is "and" as you travel down the tree. So you start at the top and you say that we are looking at all people who have this income and who do not have children at home and who were born before 1967 and who have total number of children, not one. Do you get it? Okay. So spend a little bit of time with your data, and you'll get an understanding of your data. You've explored your data. That's useful. That's what customers pay me for. But you can go one step further. And that exciting step is, of course, making predictions. So how about we use this knowledge, this intelligence, this model, now to predict how many purchases my not yet customers would make from me? Shall we do that? All right. You remember I have a table here called new customers. We've been looking for exceptions in it earlier. And notice that in this particular table, I don't have any information about how many cars they bought from me. I don't have any information about the profits they generated. I do have, however, a column called number of cars owned. So just to make sure that I'm not cheating, I am going to actually delete that column altogether. So nobody in the room thinks that the algorithm basically looked at how many cars they've got to predict how many cars they will buy. No, it wouldn't have done that. It wouldn't have done that because Excel and SQL Server are decent and honest. They don't cheat, all right? But just in case you didn't trust it, you know, this is Las Vegas, I have deleted that. So it's definitely not there. I'm selecting all of my data. I actually don't need to select my data, but I kind of like playing sometimes with a mouse, but obviously today it's not working. So I'm not going to select the data. Rather than that, I'll press AE, which normally does that. I go to the Data Mining tab. I make sure I am still connected to the same database to which the previous model was written to when we have built it a few minutes ago. And now I will use the Query button. The Query button basically performs predictions using a model. It queries a model. So I hit the Query button, and I am immediately asked, where is the model you want to use? And it usefully highlights the most recent model we've worked with, which is exactly the one we want. Sorry, my scroll bar seems to be disappearing. As soon as I magnify it, oh, there it is. Can you see that's a number of purchases model that we have built a few minutes ago? And in case you are lost as to which model is which, just look at which algorithm you used, what's the output, what were the inputs. That's the model I want. So using that model and using the data which is in my table of non-customers, I will now match the columns in the mining model onto the columns available in my table. And I cannot match the number of purchases or profit generated because I don't have that data about my customers. No problem. It will absolutely work fine because it will predict using as much data as you have. Having said that, if you are missing a lot of input data and you really give it like nothing, the accuracy of the prediction will be low. So if you are doing it professionally, you should predict not just the outcome, but also the probability of the outcome and a few other statistics of it. But you don't need to do that whilst you are enjoying the session over here today with me. So we'll glaze over that and we'll just say, nothing to worry. We hit next. And now it's asking me, what is it that you would like me to predict? Let's add some output. The output that I shall add is a prediction of the number of purchases. And by the way, I just told you that you should also be predicting some probabilities. And even though not everybody likes to hear about probabilities, which is why Las Vegas was built, you can predict them just by clicking on those few rows over there. So just to demystify it, I'll predict one probability just for the fun. Calling output 1 is not very useful, so I'm actually going to call it the predicted number of purchases. And I add that as my output number 1, and I'm going to add a second output, which will be the probability that somebody will buy 4 cars. So, prob of buying 4 cars. All righty. I've got 2 outputs to predict. I hit next. Excel is asking me, where shall I give you the results? Yes, please append them to the input data at the final columns. I hit finish, and you'll see how fast it is when I hit the button. It's got 4,000 rows to perform prediction on. Many data mining tools are nowhere near as fast as SQL Server. And finish and done. So 4,000 predictions later, we find out how many purchases these customers are likely to make based on where they happen to be in the decision tree. And you also get the prediction of the probability of buying 4 cars. So if I sort that from largest to smallest, indeed, I can see with a very high probability those who are likely to buy 4 cars, and as that probability decreases, you can see that the number of cars being predicted also has decreased. How easy was that? And you could do exactly the same to predict the profit potential of a customer or the risk score. Of course, there are famously well-known credit scoring agencies that will do a great job if that's something you require, but you could also build your own model which will use your data rather than generic models, and you could compare which works better for your business. Well, I've shown you already quite a lot, but I have 9.5 minutes left to show you a little bit more fun. But before I show you a little bit of more fun, I have to show you something that's boring but important, and then there will be a little bit of fun. So, the boring but important, and just to spice it up, I will show you using SQL Server data tools, which is this other tool for working with data mining. I want to show you how to validate model validity, how to check that my models are accurate. This is the educational data set that we are using in the videos, that, by the way, also has the number of purchases model at the bottom that we have just built. And what I'm going to do is I'm going to quickly look at that model, and you already know that model because you've already seen it in Excel. So basically, this is exactly the same stuff. It's just running in a different tool now. But I want to show you this tab, which I'm very sorry to say seems to be slightly broken at the moment in Excel 2013. And I'm sure they'll fix it. I'm sure they'll fix it. So that's why I switched over to this tool. I'm so honest. I should have said absolutely nothing. You would have thought I'm just, showing you another tool. Now, every presenter has a reason for showing something. And this is the reason. This is the reason. Everything else works. That's the only thing that seems, and not always. It's like sometimes, sometimes not. Is Yigal in the room? Yigal. Is Yigal in the room? He's hiding now. Okay. All right then. Never mind. Never mind. Mining accuracy chart. Show me how accurate is the model for predicting 2 car buyers. And here is the lift chart. Ooh, this is pretty good model. Pretty good. Pretty good. What does it mean? The first time somebody explains a lift chart to you, it's like a new day. I do not pretend to be Celine Dion, but I will tell you what this chart does. It's very, very easy. Basically, the blue line is randomness. The red line is a crystal ball, Madame Zaza, who can predict really what will happen in the future with 100% accuracy. You can find them on the strip. The green line is my model. And what you are looking for is a line which is as far away from randomness and as close to perfection as possible. What does it mean? What it means is that this is your caseload. This is the number of people you talked to. If you were to send expensive wine to 50% of people on your customer list randomly, you would send it to 50% of potential targets, right? However, I know that 2 car buyers in my company happen to be 44% of people. 44% of all of my customers buy 2 cars. So if I had Madame Zaza's crystal ball, it would tell me exactly who are the 2 car buyers. So I could send that expensive gift straight to the right person. So if I had Madame Zaza's crystal ball, I would only have to talk to 40% of people to hit 100% of people of interest. Whilst if I do it randomly, and I send the gift to 40% of people randomly, I will only send it to 40% of people of interest. And in the middle, there's my lift. In the middle, there's my model. And it's powerful, because if I send that gift to 40% of people, I have reached almost 80% of the target audience. And that is why we use mining models. Because instead of having to contact everybody, you are contacting a much smaller proportion that has been carefully selected by the model because it knows something and because it can select them. In fraud, this line would be here because there's so little fraud that if you had the magic ball, you'd be hitting this point straight away. 3% maybe in some companies, 2%, 5%. But we don't get that. But you can have a model which, given 20% of the caseload, predicts 60, 70% of likely fraud. Those are enormous savings and enormous power. And that's what you are looking for. And incidentally, if you do play with this, have a look also at accuracy of different techniques. For example, here, I am comparing the power of different models built using a decision tree, green, clustering, purple, and a neural network, yellow. And you can see that for this data, decision tree is the best, neural network is second, and clustering is the worst. And you could compare all of the models next to each other using this tool. Okay, but the session title said that it's all about Excel, so I'm going to switch back from SQL Server Data Tools, and I'll go back to Excel for the final demo of my presentation, in which I want to show you market basket analysis. In other words, how do I predict what will my customers want to buy based on what they already have bought? This is probably the most common request you will get if you operate any kind of a commerce website. So let me show you how you could do exactly that. Let me close those two Excel spreadsheets, and let me open a spreadsheet that contains very simple data. Data that just represents orders. For example, in this order, number SO61269, somebody bought a helmet and a jersey. And specifically, they bought a Sport 100 and a long sleeve logo jersey, and this is how much they paid. And I happen to have not an awful lot of data. It's only about 32,000 rows representing sales. I want to know, is there a pattern? And in order to do that, I'm going to show you how to do it in two ways. First of all, I select the data. I'm going to go back to my Analyze tab because this is the button you want to press, Shopping Basket Analysis. It's kind of amazing that there is a button in Excel to do that because there are tools commercially available that charge you $25,000 for a user to give you exactly that button. And it's a nice button, isn't it? It's like a little shopping trolley with A leads to B. All right, so let's press this button. Let's press Run. Off it goes, data to SQL, blah, 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 some data mining, and results come in a moment. And you've just learned that the most popular bundle is a road bike sold with a helmet, which was sold 805 times. And you now think, yay, we're going to promote road bikes and helmets. Don't do that. Why? Because the most popular bundle doesn't have to be a bundle for a reason. Why? Imagine a store which only sells road bikes and helmets. That would become the most popular bundle. You don't want that. What you want to find out is the probability of selling road bike with a helmet, the probability of selling road bike without a helmet, the probability of selling helmet without the road bike, and the probability of not selling the helmet, not selling the road bike. You want to multiply them over here, you want to add them over here, you want to divide one by the other, and you want to flatten it with a logarithm. Or you can just open this sheet, which is here. And you have just learned, thank you very much, you have just learned that really promoting fenders will lead to sales of mountain bikes. Cleaners will sell tires and tubes, and so on. And you can also view it in more level of detail if you wanted to. For example, we've done this analysis at the level of categories. But how about I do it not at the level of product category, but actual products? No problem. Press Shopping Basket Analysis once again and make sure that the item column is not a category, but it is the actual product. That's all I am changing. At this point, I hit Run. It goes out. It does. It takes a little bit longer because it has a few more rows to analyze. And now we know that the actual most popular product bundle, or the item set, is a fender set with a mountain 200. And in terms of the recommendations, a mountain tire tube will definitely sell Sport 100. And you can guess why, because, of course, mountain bikes, some puncture their tires, some are quite frequently. And, of course, there is a visualization for it, too. And if you don't want to look at tables, all you need to do is go to the Data Mining tab and use the Browse button to open the underlying model, which has been built over here. This one, as you see, was built at the level of categories. This one was built at the level of the product. So let's use this one. You hit Next. And after a moment, you switch to the Dependency Network Viewer. You clean up quickly the display. You make it a little bit more visible. Let me, it's not very visible. Okay, I'm going to just zoom in so you see. And you might want to reduce or increase the strength of links. And for example, you see that HL Mountain Tire sells mountain tire tubes, which sell bikes. Or a patch kit is linked in those wonderfully interesting ways to other products. A road bottle cage sells water bottles. Mountain bottle cage also. Okay. In the last 30 seconds of my presentation, I just want to show you something that I'm completely not going to explain, but you might find it useful. In case you ever wanted to code it, for example, for your SharePoint site, so that it automatically performs predictions for your shoppers, for your buyers, there is a way to do it programmatically. This is a query which says, in the basket, I have a patch kit, make recommendations, execute. Let's recommend to them LL road tire, mountain tire, and so on and so on. All you need to do is to copy and paste from either my videos or from the screen or from the PowerPoint. No, it's not in the PowerPoint. You have to get that query right. That's basically the query behind the scenes that automates what I have been doing for you by clicking on the buttons in the user interface. Okay, ladies and gentlemen, I hope that in my presentation I have given you just a taste of what data mining can do and how it discovers hidden patterns in your data. I hope you understood that SQL Server is the brain, whilst Excel is the interface. I hope you have taken note of those codes. I don't know how many are still remaining, but I hope there are still a few. And the only thing that I would like to ask you please to do is to fill in the evaluation form. And if you have attended yesterday's seminar, please fill in the evaluation form. If you fill evaluation forms, they invite me to come back. If you don't, then I cannot come back. So please do that. You've been a wonderful audience. Thank you very much.